Hello student. So we will start the new topics on Newton's law. Basically, we will discuss about the forces, mass and motion. So in this video session, we will discuss the force, mass and the definition of there are the motions also. So after that we will discuss on the two laws of the Newton's, the first law and second law, with brief explanation with the example. So we will start. Okay, please wait and I will share the screen. After that we will start. Okay, so here are the So this is the Newton's laws of motion. Okay, now when we are talking about the Newton's laws of motion, guys, so it is nothing. Basically, there are three fundamental things. There are three fundamental things. First is the mass. Another, when this is the motion, and third is the force. That means when we are talking about the mass, what is that what is the mass? So in the physics meaning, or you can say that in a physics, so they are the quantitative measure of inertia. That means it is the fundamental property. Okay, it is the fundamental property of all the matters. So it is an effect. What that affects the resistance of all matters. So it is so the body of matters offers to change or in its change in its speed. Okay, their speed, and you can say that their position or its on position upon the application of the forces. Okay guys, so basically when they are the greater the mass, one we have to learn, if they are the greater the mass of the body, so the smaller the change. Greater mass, small change. Okay, so which is produced by the applied or you can say that the forces after the applying force. So it's a smaller change if they are the big objects, so their mass is also large. Okay, so this is the mass. So after that, when we are talking about the motion, that means the motion, what is that? The motion. Okay, so the motion is in the concept of motion in the physics, so it is the change with the time, or you can say that the time of the position or orientation of the body. The main thing is the position and orientation of the body. Okay, so another is the motion which along a line, or you can see that a or a curve, which is called a translational. Translation, that it is also the motion. Translation is also a motion. We will discuss in next video session. Okay, so the motion that changes, when we are talking about the motion is change, that means their orientation, basically the orientation of the body, that it is called a rotation. Okay, that is called a rotation. So in the both cases, there we discuss the two cases, guys. First one is the translation, another is the rotation. That means in the both cases, all the points in the body have the same direction. Okay, or same velocity, that means directed to the speed, or same acceleration, guys. Same acceleration. What is you mean by acceleration? That means the time rate of change of the velocity. That means they are the rate of time which is changed according to their velocity. Okay, or you can also say that the velocity will change according to their time. Okay, now most of the general kinds, you can say that they are motion which combines both of the translation and rotations. Okay, now this is the main or general fundamental concept of the motion. Okay, now we are discussing on a force. What is the meaning of the force, guys? So whenever we are talking about the force, so in class 6, 7, we will also we had also study there. So push and pull is a force, but in 11th class we will discuss in a brief way about the force, about their laws of Newton's. So obviously the force is a push or pull. So what is the push and pull, or how we apply the push and pull? So this is the push or pull upon the objects, upon the objects. So they are resulting from their objects interaction, okay, with another objects, okay, with another objects, or you can say that there is enough force upon which uh, each of the objects. So there are the interaction cases. Okay, there are the interaction cases. Suppose there are the two objects no longer experience of the forces. Okay, the force only exists as a result of the interaction. Okay, suppose I have a, this is the objects. Please see, it is the object. Okay, now if it is stay here, if it is stay here, that means it is, they have no any forces. Okay, they have no any forces, no mass are there. So this is the second law. So we will discuss another slides. So please understand the force. If if this is push, so that means if this is push, so this is just moving, just take a take a some distance. So that means this is the force. If this is the object, if this is the object and I doesn't apply any forces, so it doesn't have any force, it doesn't have any mass. So we'll discuss in a second when we discuss second Newton's law. Okay, so this is the force. Now we have the two definition of the force. What is that, guys? First of this is the definition. We're talking about the definition is nothing. Okay, so the simple definition that the inherent forces of a matters is the power of resting, or you can say by which everybody or as much of the initialize continue. So it present whether it be the way be a rest or is moving uniformly forward the or light line. Okay, that is the straight line also, you can say that. Okay, so this is the definition of forces. When we are talking the general definition, so general definition is nothing. The definition is, you can say that the definition of the forces, it is which is an action exerted upon a body. So in order to the change the state, or it's either rest or moving uniformly forward in all direction. So that is the force. Now we will discuss a scenario based. Okay, suppose it is a force. Okay, suppose it is a force. Now anything without we apply any forces on this object, what you say that basically they have no anything. If I pull or push, if I pull or push, so this, after that apply the force, after that you can say that this is the force. Another thing, if it is a moving, if it is a moving and when it is moving and when we apply the force, this is the force. If it is the moving and we don't apply the force with another object, that is called no force. So this is the moving positions. Okay, So this is the definition of the forces. So we will discuss Newton's law. There are the three laws. Sir Isaac Newton, mm, Sir Isaac Newton gave three laws. First law and second and third law. So in this video session, we will discuss the two law. Okay. So first law is a Newton first law of a motion. So we will start the Newton first law of the motion is that they, there are slides. The pictures are given in your screen. So they are the footballs are here. Okay. So if if the football are here is only in a race. So this object at rest will remain at rest. So there are no any mass. I just explained before the slide. Just explained before the slide. So that time I took a objects and explaining their things. How can we say that? That is the force. So same thing here. They are the football in the first row. So there are the object at a rest. That means they remains, or you can say the all the things are in rest. Okay. Now this slides, the second picture says that any footballer or any person kick that ball. So this kicking that ball, we can say that this kicking that ball, we can say that there are push, there are push on a or kick on a football, so they move some change or their state will be changed. So this is acted by the unbalanced force. What you can that? Or you can say a suddenly kicking or suddenly push, that is unbalanced force. Okay, that unbalanced force, that unbalanced force is after that the ball will slide. The ball will slide. The third picture says that the object in a motion will continue with the constant speed or a direction because the speed is constant. That is uniform speed. Okay, how we say that in uniform speed? Basically, the kicking of the force, they are the motion which is in constant. So their direction is the one-way direction, you say that. Because if they not collide anywhere, then it will doesn't change its direction or its direction. Okay, either it's stop or it's continue going on. Okay, but it is stop. And last picture say that there the acting on by the unbalanced forces. The football is collide with the nets. So this is the Newton's first law of motion. So now we will definition simple definition of the Newton first law. So everybody continuous its state, okay, of rest or of uniform, which is rectilinear motion, okay, except if it is compelled or by the forces, okay. So it's acting, it changes to the state. So they are the force of first law is also can say that inertia law also. So we will discuss in our next video session what is the inertia. That is the big topic. When we will discuss on the inertia of the motion. So basically it is the big topic, and we will take there 30 to 40 minutes are there. So if you will understand the inertia, that means you will understand the Newton's first law and second law also. Okay, because of third law is simple as that, but they are also the that or a video lecture on a third law. So also will take approx 30 minutes. if we will discuss in a brief way. Okay, so now we are talking the law 2. What is the second law of the Newton's? So there are the changes. Firstly, we will discuss the definition of the status definition. What is the status definition? Are there the change of the motion, which is directly proportional, or which is on a applied force. So it's take a place in a direction or in a straight line, which along which that force acts. Okay. So what is that? So will explain here. Okay. So how can we explain that things? There are on your screen. There are the two aeroplanes are there. So in the most side, aeroplane says it is in waste. That why how it came it is in waste. So they are explaining velocity is zero, mass is zero. Okay, so t is zero, x is zero. After that, the force is exerted on aeroplane, or you can say that it is starting to fly. So there are the V naught and naught, that means initial velocity, initial mass, initial time. T naught say that initial time, or x, that means initial location. So when we'll discuss on a graph on these parameters, so location are also important. So x naught is which is define the location. Okay, x naught is a define the location, guys. So then the force is in a second law, change of moment with the change of time. That means their moment will change with respect to their change of time. How can we say that? There are different forms. There are the two forms. One is the initial velocity, initial mass are there, initial time are there, or another is the initial locations are there. Okay. So after when we'll see on the screen, there are the another leftmost side are there. There's a V1, M1, T1 and X1. These order the time, location, mass and velocities are also there. So after that, we find the difference of the form F equal to M1 V1 minus M0 V0 divided by T1 minus T2. Okay, this is what is that? This is the difference. How we can calculate the difference from. Okay, when we are talking, if we'll take mass will constant, if we'll take mass will be constant, is it possible? Yeah, is it possible? If we will take mass will be constant in these scenarios, so m is the take a common because m1 equal to m0. So obviously their mass rightmost side, they are the rightmost side, the picture say that initial mass, if it is in race, so mass is the same with respect to the uniform speed of the any objects. Okay, so m naught 1 equal to the m naught. So we will take the m common. We will take the m common into v1 minus v naught divided by t1 minus t naught. Okay, okay, guys. So is the state. Now you will understand about, or you will knowing about acceleration. What is acceleration? So m naught in the second form with a constant mass, they are the m into v1 minus v naught divided by t1 minus t naught. That is the acceleration, because of there are the final minus initial velocity divided by final time minus initial time, which is in acceleration. We studied in we studied in speed. Okay, so F m into a, that means force which is equal to the mass into acceleration. Okay, so they are the velocity, acceleration, moment and forces are the vector quantities are there. Okay, they are the vector quantities. This is the second law, says F equal to m into a. We will understand there the function, or you can say the equation are there, F equal to ma. We will understand force directly proportional to mass. Now there there's motion is proportional to the applied force, so it is propare. It is proved their force equal to mass into acceleration. What is that? Mass into acceleration. That means mass into acceleration means F directly proportional to the mass. Okay. If F directly proportional to the mass, if mass, or you can say that the object is large, if object is large, so the force, when we apply force on that object, so we have to apply there more upon the force upon their objects. Okay, if the mass will be small, if the you can say that if object will be small, that means their mass will be very few things. So we'll discuss in the slides here. So on your screen there are the two-person, one for the leftmost side, they are the mass, they are the person which pushing on an object, their mass is 400 kg. That means they have to apply more forces on that object, then their state will be changed. When we are talking about the second picture, that means right most side picture, they are the person they have the push, actually they are pushing on the objects. That means they obviously this is happy, that means their object is small, so 40 kg only, and they easily pushed away because they don't have more forces applying on them. Okay, but in the first picture says that they have to difficult, so because they forces more. Okay, because their object will be large or their mass will be large. Okay, so this picture says that the perfect explain there the second law of the Newton's. Okay, so another video session we will discuss on a third Newton's law. So that takes approx 30 minutes. Okay, when we will discuss in you can say when we will discuss in a brief, or another is inertia. It's very important topics that compared to the concept we'll understand compared to the engineering background, the examination, JEE Mains, the advanced are there. Okay, so now we will now thank you so much guys. So please stay healthy, stay home at healthy. Thank you so much.